The life of all stars first begins in the nebula. A nebula is a cloud of dust, hydrogen, helium, and other ionized gases. In the nebula, dust, gas, and other materials form together to form protostars. A protostar is a large mass formed from the gases and other materials in a nebula in the earliest stage of star formation. This stage takes course over millions of years till eventually the protostars reach a state of balance and finally turn on their cores and start nuclear fusion. If a protostar never reaches a state of balance and turns on its nuclear fusion, it then becomes a brown dwarf. A brown dwarf is a stellar object too little in mass to sustain hydrogen-powered nuclear fusion. Once a star starts nuclear fusion, it will fuel the star for most of its life. During nuclear fusion, a star will eventually run out of hydrogen atoms and will then begin fueling helium atoms, causing the star to grow in size. It will pass the subgiant stage and it will become a red giant. Larger stars will be able to fuse heavier elements and become larger supergiants. When a star has exhausted its nuclear fuel, it becomes a dense white dwarf with its outer layers expelled as a nebula. With larger stars, they can explode into supernovas. Supernovas are stellar explosions that briefly shine and radiate with as much energy as the sun. As their ion cores collapse, the star becomes extremely dense neutron stars or a black hole. A neutron star is the stellar remain of a collapsed star. The star is almost completely entirely made out of neutrons, and its density is so heavy, 1 grain of sand is equivalent to the weight of a wide-body airliner. A black hole is a region of space where gravity is so intense that not even light can escape. These larger stars must be at least 10 times or larger than our own sun in order to become these objects. The debris left behind a supernova explosion then becomes a nebula, and the process of birthing stars begins yet again.